Hello, everyone. Welcome to the Incubator Podcast. This is your co-host, Sadbir Strand.
And this is Darren Boyd. And today we have the pleasure of talking with Adam Kamor, who's co-founder and head of engineering at Tonic. Tonic is a really, really interesting company. We're excited to speak to Adam. Founded in 2018, well-funded, $45 million to date. And they're doing something really, really cool, which is they specialize in synthetic data for test data management, test data creation. We're going to get into why that's really, really important, especially when we look at and consider that data is very contextually dependent. And so as we start mashing these data sets together, it really changes the risk profile. It changes what we have to do from a security perspective. So we're really excited to have you on, Adam. Thank you for joining us. And if you wouldn't mind, maybe we'll turn it over to you. You can introduce yourself and then maybe get into why you felt the need to start a company like Tonic. And we'll start from there.
Sounds great. So first off, thanks so much for having me. Excited to be here today to talk about Tonic and big data and everything else that we're going to talk about. So like you said, my name's Adam. I'm the head of engineering at Tonic, and I'm also one of its co-founders. Oh man, why did we start Tonic? So I think at the highest level, we started Tonic because it solved a problem that myself and all of my three other co-founders had all faced in the past, which is I need data to do my job. I can't access the real data. So what do? Well, okay, so you know the answer being, of course, that you use fake data, but not just any fake data. You can't use like fake data that's not similar to the real data. It can't just be like crappy data that's like basically drawn at random. It needs to be realistic looking data, and like that thought right there is really what started Tonic. We wanted to be able to provide our users with a tool that gives them data that looks and feels so real that they don't actually realize it's fake. And that's kind of how it got started. And since then, it's just been kind of a roller coaster ride, both, from the go-to-market side, but also the engineering side on being able to get to that point, because it's not a trivial thing to do.
Yeah, I think that's the one of the things we've found in the past is this is an exceptionally complex thing to do. If you're really going to look at the schema, you look at the upper and lower bounds, you look at the data distribution, to be able to take that, represent it, and bulk it with synthetic has historically been very, very difficult. And a lot of folks have, a lot of organizations have a skeptical view on whether or not that's usable. So we're always striking that balance between security and utility, of course. But you've been able to do this. Can you talk about the problem of even being able to analyze a data set and then represent that with fake data, and how you've kind of overcome some of these challenges, especially with the organization that says fake data just won't work for us?
Right. So yeah, there is a lot to unpack there. So I'm probably going to go on various tangents, and you'll have to bring me back. But I'm going to do my best to stay on it. So for your listeners, let me first say that traditionally, that is when the company first began, Tonic operated exclusively on databases. That's no longer true. We have many different offerings related to data in various forms, but initially we worked with structured data, typically housed in application databases. Think Oracle, SQL Server, Postgres, etc. And then the goal of Tonic initially, and this is the goal that we accomplished eventually, was give us a production database. This is the database that has production data in it, and we're going to give you back a database that is structurally and schematically identical to production, but it's devoid of sensitive information. And then the real challenge with that is, well, there's like, okay, well, what about the statistical properties of this column? Like, okay, it's a column of incomes. How do we maintain the average, standard deviation, things of that nature? That all, I think we could solve fairly early on. It's challenging, but it's solvable. The real problem is here you have an organization. It's a bank, it's an insurance company, what have you. They've been around for many decades. Their application database or databases, they can have multiple, is going to have thousands of tables in it with tens of thousands or even hundreds of thousands of columns. Not all of like the relationships that the application is going to care about are enshrined in the foreign keys and constraints of the database system. So like the application might make an assumption that, okay, well, if the value here is 1, the value over here must be 2, 3, or 4. It can't be 5, 6, or 7. And if it is 5, 6, or 7, the application will be unhappy and it's going to crash or exit or throw an error. right? So being able to satisfy all of these like assumptions that the application makes about the shape of the data is the real challenge to all of this. And companies are right to be doubtful that it can be done and that fake data has utility. It is it's a hard problem to solve, and especially for customers with larger legacy systems. And that's just the reality of it. And it can't always be solved perfectly, but it can typically be solved to the point where you can get really good value out of the fake data that we generate. To add a bit more to this, a lot of customers come to us initially, not a lot, but a subset of customers come to us initially saying, we don't want fake or de-identified data. We want data from scratch. So we want you to basically just like look at our schema and then fill an empty database with data according to the schema. And that is and I don't want to mince words here, that is an impossible task. And one that even if you could do, you wouldn't want to do. And then the reason is, we talked about like these large complex applications having all these crazy assumptions about the data. Unless you know all of them, and no one in your org will know all of them, you can't go and create data completely from scratch. You have to start with actual production data to create your fake data. Like doing it from scratch, unless you're working with a very trivial database with only a handful of tables and not a lot of complexity, you're not going to be able to do data from scratch. Like you're always going to have to start with like the real data, de-identify it, do a bit of synthesis if possible, and then give your customers back the fake data. And that's always been our belief and approach.
Adam, so we talked, or you talked about how or where Tonic began. So how were or are organizations coping with this dilemma? Clearly, you're solving a need for it in the marketplace, as you highlighted. So what were some of the techniques or typical situations that organizations were running, or what were they doing before Tonic? Let's put it that way.
Right. Yeah. So long ago, I say long ago, let's just say 10 years ago and more, I think it was very common for companies just to use production data in their development and staging environments. Basically just unrestricted access, which most developers, by the way, love because it's very convenient and they can do their job, quickly and efficiently. And that's great. There's like less red tape. In general, people don't like red tape. And even when we started the company, 5.5 years ago, a subset of the customers that we would talk to, or rather a subset of our prospects would come in and be like, yeah, we're currently using production data for development and testing. They knew they weren't supposed to anymore, but they were doing it because they had no other choice. So for these customers, we were basically a privacy company, right? Well, we can say, okay, well, that's great. You are already doing the most efficient thing. And we're going to give you something that actually is more private and essentially also as efficient. And, we would basically de-identify their production data, and then they would use that instead. So great, we're a privacy company for those customers. We have other customers that come in saying, oh, we stopped using production data, 3 years ago. We have this really, really crappy staging database that we kind of like hand rolled some data for, and that's what we use. Like, it's got 10 users in it with like 30 events. We had to create all of it by hand, and it's not representative of what's actually out there in the real world. And we're missing, bugs during testing, and things are slower to develop because of it, right? So for those customers, we offered the same solution, but for them, we're really a developer productivity company. And now I'd say, that's 5 years ago. Now it's been a couple of years since I've come across a company using production data. Most companies at this point are just working with staging and development databases, which are just very poor impersonations of production. And they are missing bugs and shipping bugs because of it. So they're coming to us, asking us to basically make their development teams more efficient, to shift them left in terms of, QA, by giving them basically something as good as production for development and testing.
Yeah, thank you, Adam. So just building on that little bit of the theme of what were people doing, I would say if you could also elaborate further where the need for synthetic data comes in place, where traditional folks have said, hey, we could just simply mask data, right?
Right.
And so there were various techniques, various providers out there saying, hey, yeah, we do data masking. What are the limitations there that really, as you were defining, we do data creation, synthetic data. How does that play out?
Right. So this is tough because everyone has different definitions of all these terms. So I'm going to give you my definitions, and just assume my definitions for when I give you an answer. Okay. So masked data. When I think of masked data, I typically think of you give me a row of data. I mask or de-identify the columns that we consider to be sensitive, and then I give it back to you. So if you give me a column with like a primary key, a customer's name, and then a foreign key to some other table, I might only de-identify or mask the customer name. I might not touch the primary key or foreign key in that row, right? Maybe we don't consider those to be sensitive. We probably don't, right? So you give me a row with 3 columns. I give you back a row with 3 columns, and I've masked just one of those columns. And for every row you give me, I give you a row back. That's de-identification or masking, right? Like masking typically I think has a negative connotation because like people think of masking, they're like, oh, you're just replacing every letter with an X, or you're just nulling out the column or what have you. So like de-identification is essentially masking, but the techniques you use for masking are more sophisticated. So instead of replacing like X's or a name with a bunch of X's, you replace a name with a fake name, right? That could be considered de-identification. And how you actually replace names can get very sophisticated. Maybe you want to preserve things like the national origin of the name or the typical gender associated to the name. Or maybe you come across the same name multiple times in different tables and you want to mask or de-identify that name to the same fake value each time to do it consistently so you can preserve like joins between columns, right? So there's the masking and then de-identification, which is like masking on steroids. We do a lot of de-identification. Of course, our data transformations also allow you to do, simple masking, I would say, if you wish. It's really up to you. The tool will let you do essentially what you want. And then on top of that, you have synthesis. So in masking or de-identification, 1 row in, 1 row out. In synthesis, it's more about like taking in an entire data set, understanding the mathematical relationships between columns and rows, and then giving you back this model of how the data is represented. And then given this model, you can go and generate new rows. But the rows that you generate aren't tied back to specific rows in the source data. They're more just our understanding of the relationship, and they're representative of that. So with synthesis, I can generate as many rows as I like, right? Like you give me a table with 100 rows, I understand all the relationships in there. And then whenever you ask me for a row, I just pick one, based on my understanding, or rather I generate one based on my understanding of those mathematical relationships. And I can generate for you as many rows as you like because they're not tied back to the source rows at all. So that's synthesis. So synthesis is like, I'd say a level up from de-identification, but it has pros and cons to synthesis. Like synthesizing data, synthetic data is not always the answer. And oftentimes de-identification will be preferred. But those are all my definitions, and I'd be happy to talk about like specific use cases or really whatever you like.
No, I think they're great definitions too. We've seen folks take almost a safe harbor approach where they say, here's a checklist of things I need to accomplish. And if I check all the check boxes, I should be okay, right? And then what they're finding now is, like if you look at GDPR or PIPL or there's a number of regulations which take data privacy so much further. And one of the things that's stated is I don't necessarily have to re-identify a row to say Adam Kamor. I can just single out. If I can single out, technically I have re-identified that row. And that might be enough to warrant a violation. And so I find that your techniques are, and I need the readers to understand this, they are extremely advanced. Not only synthetics, which you do so well, but how you're analyzing data sets. One of the things I love about Tonic is like there's folks that like even if you look at Google and BigQuery, they can do K anonymity, they can do L diversity, they can do so on and so forth techniques. But so far, you're the only one I've seen that has taken I think it was a 2016 paper and applied differential privacy as well. You are taking privacy so seriously, and so it's like you said, you're doing masking on steroids with your de-identification. You have an incredible number of generators to make that possible. You have a lot of advanced techniques in those generators. You can do a lot of statistical. You preserve statistical relevance, and now you're applying differential privacy as well. Can you walk through how folks are how InfoSec is consuming this, why differential privacy is an interesting technique. It doesn't apply to all areas, but it certainly is, like, you are a security first company when it comes to data. Can you talk a little bit about some of those techniques as well?
Yeah, absolutely. So, as you said, not all of our transformations, but some of our transformations do support this notion of differential privacy, which is I'm by no means an expert here, but I'll give a layman's definition. Differential privacy is essentially like a privacy framework that if one follows the framework and if one follows the kind of, if one uses algorithms that are differentially private, then you can get certain mathematical guarantees about the output data set, meaning like, okay, this data set was generated using differential privacy. And then I kind of know what's the worst thing that can happen if an attacker gains access to my differentially private data set. And then it essentially does this by injecting noise into this original data, which provides the owner of the data with plausible deniability about what's actually contained in the data set. At a high level, that's what's happening. So a subset of our transformations are the transformations, meaning the mathematical operations that we apply in your data to de-identify it, are differentially private. And in general, they all follow the same theme. And the theme is they remove outliers from the data. Outliers are very dangerous for being able to re-identify individuals. Like you mentioned, I think you're in the context of GDPR and other regulations, it's not necessary that you just have to, re-identify this value to Adam Kamor. But if you can even single out records associated with me, then you can potentially be in violation, right? Well, one really easy way to do that is, let's say you have your data is it's an insurance data set, right? Like maybe like life insurance policies, right? Well, you have one guy. He's the CEO of some big tech company. He makes a lot of money. He's got a massive policy, and he goes skydiving. And it's like public knowledge the guy goes skydiving, right? This individual is an outlier in the data set. What do you do about that, right? Well, you have a few options, but the safest thing you can do is you can just not put them in the output data set. Because if you do, you're possibly going to run into trouble. So being able to remove outliers is the common theme that our differentially private transformations have. Of course, when you remove that outlier, you are kind of hurting the utility of the data set, right? Like the data set's now a little less interesting, a little less similar to the source, but it's much more private. And it goes back to what you said earlier about that data utility and privacy trade-off, right? Like you don't get both. You get one or the other. You can either maximize privacy and you hurt your utility, or you can do the opposite, more utility but less privacy. So, Tonic doesn't really necessarily as a company take a position on what's best. It's kind of very much use case dependent. And Tonic is a tool that just kind of lets you strike the right balance yourself for what you want to do. And in this case, differential privacy is an option, on some of our transformations. So, it's up to you whether you include the tech CEO that likes to go skydiving with adults. But you need to understand the risks.
Well, what I like too is if we're dealing with fake data, it is already differentially private. You cannot, using synthetic data, you cannot re-identify anything, so you're safe there. The other thing I really enjoy about Tonic is we often preach this idea of data minimalization. So instead of just copying a whole data set or a whole database and then using it, even if it's masked using some advanced techniques, I would suggest as kind of an opening position that that's not really following this data minimalization concept. We should be minimizing our data for the test at hand, and that's it. And then we should not release and persist that data. You should tear it down after, and so on and so forth. This is something else that Tonic supports. You can do subsetting.
That's right.
You said it earlier, when you look at a row and you're going across, not all columns necessarily need to be masked. You are applying techniques to say these are identifiers, these are quasi-identifiers. Yes, you should maybe mask both in this case, but oops, you've brought in other data sets, you've connected them with foreign keys, and yep, based on this new data set, this new aggregate, maybe we have to mask more. So you're helping folks kind of navigate this, but you're also supporting this idea that you can subset. We only mask the things that we have to, which means you're straddling something that's extremely performant. You're following every best practice out there. And with the advent of synthetic data, you're absolutely safe. I'd even suggest that Tonic has that slider between security and utility. And the user gets to decide how secure you want to make that, or how utilizable. Well, anyway,
Yeah, the utility of.
the utility of. So then maybe you can talk a little bit about the performance and the general architecture. What can people expect when they come to Tonic and say, let's take this for a proof of concept?
Sure. Oh man, so performance. Performance is almost impossible to talk about at any level of detail without understanding. No, I'll give you a good answer though, I promise. It's almost impossible to talk about, at any real level of detail without knowing the system on which Tonic is running. So in general, our solution is bottlenecked by IO. So it's going to be IO constrained, meaning like the slow parts are not the actual processing happening on the CPU where it's doing all the number crunching. That typically is fast. And if it's not, you can just deploy on more machines or machines with more CPUs, and you can get nice speed ups that way. So typically what ends up happening is the slow parts are either going to be the network, the network, the pipe moving the data from the database into Tonic and then to the output database, or it could be like on the hard drives of the databases themselves, either reading from the source database or writing to the output database. So those are typically the bottlenecks. With that being said, depending on the database that Tonic is operating on, like the typical rules of thumb are different, right? Like I'd say like if you have a 1 terabyte relational database, depending on the size of the database and your setup and where you're deployed and all of these things, we can process a terabyte of data in maybe 12 hours, something of that nature, if I had to guess. But that's on relational databases. If you're working with, flat files, maybe you have Databricks or you have a cloud warehouse like Snowflake. On those databases, there's really no practical limit, just because the way those databases scale. Like we have customers processing 50 terabytes daily on Databricks, right? Which is a terabyte it's 2 terabytes an hour, essentially, right? And they could go faster if they wanted to. Just by upping the compute on their Databricks cluster. So it's all very dependent on hardware, I would say. But like you said, okay, so then there's performance, and then there's just the general notion of deploying. So most of our customers, and this is more true for larger customers and less true for smaller customers, deploy Tonic on their own servers. So, Tonic is typically deployed in a public cloud, AWS, Azure, GCP, what have you, by our customers. Tonic gets packaged up as a set of Docker containers. We have Helm repositories, Docker Compose files. We support AKS, EKS, all of them really. However you want to deploy and manage Docker containers, you can use that methodology for managing and deploying Tonic. So Tonic gets deployed on our customer servers. All of the data that it sees and everything it does stays on those networks. Like Tonic is never sending, the tool itself is never sending data back to our servers. In fact, many of our customers run Tonic completely air-gapped. So they run Tonic on servers without, public internet access. Just to give you an idea of like what the tool can do. So we also have a cloud environment. Many of our smaller customers, especially, use our cloud environment. We have various certifications to let you know that we're serious about your data security and that this is a safe thing to do. So customers get deployed. We'll just say they're on-prem for now. And then typically what we see is there's always like those initial steps, there's always like the initial work of like getting the database de-identified the first time, right? You go through this process once. You got to figure out like all the transformations you want. The tool does a good job of helping you and kind of speeding you up and helping tell you like, hey, that's sensitive. Hey, you can ignore that, etc. So you get your first like de-identified output, and then our customers typically start thinking about automation. Like they want this to like, you don't want to de-identify your database one time and then not do it again for 3 years, right? Like your database is changing over time. You want to keep your de-identified database up to date as well. So customers typically then start thinking about automation. Like, of course, they could go into the UI every 3 days and start a new job, or they can use like our REST API to kind of like automate things away. Like, a lot of our customers are, for example, on Airflow, where I don't know Airflow terminology very well, but like essentially, running the Tonic job just becomes another step in an Airflow pipeline. right? And this is all done via our API. Our documentation has tons of API examples to get you started. And then from there, some customers stop. They're happy. They run Tonic every 3 days, triggered by Airflow, and they're good. Other customers get more sophisticated, where they start, for example, they'll check their Tonic configs into source control so they can keep them up to date, in the normal course of doing code reviews. Some customers use our API for things other than running jobs. They actually apply all transformations programmatically, or they maybe are integrating us with a data catalog, or using Tonic as a data catalog and exporting findings into other processes. Like it really doesn't have to stop if you don't want it to. A lot of customers will just basically do everything via the API eventually, and really not go into the UI anymore. It just kind of depends on the sophistication of the customer and what they're trying to get out of the tool.
Yeah.
After that, I'd say there's one other workflow that I've seen customers start to do that I think is really interesting. You mentioned subsetting, so I'll just say this briefly. Subsetting is a way of taking a large database and making it smaller. You talked about data minimization. It's actually also great for cost minimization. No one wants to be running, 5 instances of a 10 terabyte Oracle database. That gets expensive real quick, right? So subsetting, makes your data smaller and also, cheaper to run. But our most successful subsetting customers, what they end up doing is they end up taking their production databases. They'll typically create a same size version for UAT and staging. But then they have their development environments. Do you really want to give ideally, each developer gets their own database, right? You could have one big dev database that everyone uses, but that kind of sucks when you're testing out schema migrations and doing heavy-handed things. It's better if every developer gets their own database. But you're not going to give every dev a 500 gigabyte database or what have you. That's insane. And they also can't run that on their laptop, or most laptops couldn't run that, right? So a lot of our customers actually subset their databases down to such small sizes that you can actually throw them into Docker containers. And then you can put these containers into repositories, Docker repos. And then your developers can just pull down whatever database Docker container they need based on whatever version of the code they have. And then they can run everything locally. And that's that to me is the ultimate, that's the nirvana for Tonic. I love seeing customers do that. And this is actually, we are releasing a set of features to turn that into a first class experience, hopefully in the next, I think month or two. In the meantime, it's all customers typically handle this via our API, but we want to add a nice UI experience around it as well.
Wow.
Yeah. Well,
yeah, it's really cool.
No, lot that you covered there, Adam, in terms of production or optimization as well as patterns. And I know we're coming up on time here. So just to bring this to a close, Adam, anything particular exciting on the horizon that you'd like to share with our audience in terms of product roadmap or just overall the marketplace?
Yes, I'm. I didn't know if you were going to ask that. I'm glad you did though. So we have a new product that I would say it's released, but really we're mostly just working with existing customers in terms of deploying it for them first. Tonic traditionally has worked with structured data. That is to say, data that sits in databases or in CSVs or Parquet files, but in general, structured or semi-structured data. JSON being an example of semi-structured. But we've typically shied away from working with free text data. For free text data, think about a chat history between yourself and a customer service agent in some chat widget on a website, or maybe the notes the doctor takes about you after your checkup, right? That's free text data. We are releasing a new offering, or rather we have released a new offering that allows you to identify and then redact sensitive information found within free text for the purposes of training text-based machine learning models. For example, fine-tuning a large language model. So the primary use case here is, let's say I'm a developer at an insurance company and I want to train a chatbot to kind of answer health-related questions for my customers, right? In lieu of them talking to a doctor. Well, I have a bunch of old transcripts between patients and doctors, and I want to use that to train my chatbot, right? But of course, I can't train the chatbot on all of our PHI information, because then the chatbot might repeat something sensitive, when it's actually being used in the future. I might say, oh yeah, Adam is 6'2", he suffers from this health condition, he has this color eye, etc. Right? That's all PHI, and that's no bueno. You can't be sharing that. So with our new offering, you can actually redact these chat transcripts, but make it look realistic still, but redact all of the PHI. Train the model on the redacted text, and then be able to use it, without concern. So, for any of your listeners today that are thinking, hey, I need to do free text data redaction and Tonic doesn't do it, well, think again. Now we do. So, we'd be happy to chat with you.
That's awesome. I was going to ask, is in the world of generative AI that we live in, how does that correlate, and how's Tonic kind of meeting that world? So great to hear, Adam.
That's how.
Very good to dive in with you here today. Thank you so much for your time, and we look forward to working with you with our clients. And for our listener base, if you have more questions around this domain, please reach out to ourselves or Tonic directly. Happy to support.
Awesome. Thanks, Adam.
Thank you so much. Have a nice day.
Yeah,
right, thank you.